So this session is about troubleshooting a network. So when you have a bunch of computers talking to each other on your own LAN, this is all about how do you troubleshoot it when there are issues. Um, and let me make sure. Okay, and you see the presentation, right? And I think because my screen is let me. Okay, I think we're on the correct.
Presentation.
Okay, so um, the first thing we have to decide is if the problem is inside your network or outside, because sometimes the problems in Africa, you never know if the internet is down or if it is your problem. So you always start by pinging an external, something that is outside. Um, and there are some excellent programs, MTR or WinMTR, Ping Plotter, something like that will actually check every step along the way. Um, and let me. So when MTR looks like this, if I go to 8.8.8.8, and it shows the different paths it has to take to get to that particular one. So if I do our organization Lightsys, it shows all the different spots. And so if the problem is outside, it would tell you partway through that it couldn't go onto that site. Um, and so a tool like this is very good for determining if the problem is local or not. Um, But most of this session is based on the fact that the problem is inside your network. There's something wrong with your network because we can't fix what's outside. So this is all about fixing the things that we can, and we can fix the things that are inside to our network. So the first big thing is to know your network. The better you know your own network, the more likely you are to be able to solve the problem. Um, So you want to be able to know a couple of servers, a couple of different things, maybe printers, and if you can find their IP address, then you can do things with it. You'll also want to know the IP address of the machine you're working from, because often you'll be able to have maybe two different machines and try to ping from each other. Um, so we use the ping command a lot, and ping will 168.1.1. It will try to connect up to something. Okay, I'm at 254. Okay, so a ping will, what it does is it sends a packet and responds if the other machine can be talked to. So I tried up here, I tried pinging a couple of things and it didn't work. Then what I did is I double checked and I said, what is my IP? When I found my IP address, it told me this is my IP address and this is the gateway. So this is usually you can always ping the gateway. And then I tried pinging the gateway and I got a good response. Um, so that let me know what kind of IPs I should be using and it, some of the pieces that we needed to go. So um, if you can, you do your tests over a wired connection, plug into the wall. The wireless has extra complications. So sometimes the wireless access point could be out, or a switch might be turned off or something like that. And pinging each one will let you know where the problem is. And so after it is working over the wired connection, then you can also try over the wireless connection. Wireless has some of the issues with it is the wireless signal can sometimes be jammed accidentally with various types of phones, or microwaves or things like that. So things that people can bring in and out might cause you problems. There is a very nice tool on smartphones called Unify Wi-Fi Man. And if this is one thing to pull from here, the Unify Wi-Fi Man is a free app. You do not have to own Unify equipment to use it, but it will build a very nice. This is a picture of somebody's house with the strength of the Wi-Fi in it. So you can walk around your house and it will build a a picture of the Wi-Fi strength in your area, and so that will help you um, determine the quality of signal in places and can help you find if there's dead zones in your place. It's a very good tool. So what you do is you can connect to a wireless SSID and you wander around, and it will help. It'll show you the map that it builds, and you can see the spots that it hasn't got, and wander around to build a good map. With wired problems, um, there's two different types of wire. When we go and we buy a big spool of wire, sometimes we put our own cable ends on because it seems cheaper than going out and buying the cables. The cables that you buy tend to be made out of what is called stranded wires, and a stranded wire is easier to bend and it doesn't break as readily. So the cables that you buy in a big spool, that one is really built for being put inside of a wall. And if it's inside the wall, you don't move it around. It doesn't need to flex. And so the cables that you have that you do buy that are like on this screen here, the little patch cable, those are really flexible. They're much more expensive because they are a lot tougher and harder to break. So it's important to realize that if you have built your own cables, those cables can break a little bit more readily, and you have to assume at times that those cables might have gone bad. I'm not saying you shouldn't use them because we all do. It's just to know that those cables can go bad a little bit more readily. Um, so if the cable is new, if you've only just made it, double check to make sure that the cables are put on well, or the cable ends. And a cable can also be broken. I've seen this a lot with chairs. I have an office chair that sometimes rolls, and sometimes they will roll it over a cable. Or if you pick it up and you accidentally set it on the cable, sometimes that can break the cable. Um, Also, your cables can have issues if you have just run a cable and the cable is run too close to electrical wiring. Sometimes that can take a signal and put it onto the cable and will make the cable make the signals much harder to get. So sometimes if you turn a light on or off, your internet is better because the power going through the cable is on or off. And then fluorescent lights. These are the big long tube lights. Those ones they flicker, and that flickering is power, the electricity flowing through it, and that if the cable is draped right next to that type of light, particularly if it's alongside it, if it goes straight across, it's not as bad. But if it goes parallel to it, that one can actually cause grief on a cable. Um, this is a fun one. I actually at the organization I'm with today, we did this yesterday, and we had to go around and reset a bunch of switches. But you can create a network loop. So a network loop, this one is a very obvious one. A cable is plugged into two ports of the same switch. And when a packet comes in, it gets sent out every port except for the one it came in on. And so it gets sent out here and it comes in here and it sends it back out here and it comes in here. And it just makes this loop. It keeps sending the same packet over and over. And this one here is the same thing. Packet goes here, it goes here, it goes here, which sends it back. And that packet will live forever and it multiplies every time. And in a short moment, it will take all your switches down. There is a special thing that you can turn on called spanning tree protocol that notices when there is a loop like that and it shuts off a port. And that's what we did yesterday is we had a loop and it shut off a whole bunch of ports on the outside of the network. And so it wouldn't let any traffic coming from the rest of the network because it noticed that there was a network loop. So we had to go to each of those switches and power them off and power them back on again to get them to talk again on the network. With wireless problems, the power is just off to it. Um, and then sometimes there's things that are causing interference. So microwaves, a cordless phone is one that you would have in your house or an office, not like a cell phone. The cell phones tend not to overlap with Wi-Fi, but a cordless phone from your home, if you have one of those stations that you can walk around your house with, that can cause problems. But microwaves are usually one of the big things in an office. People will turn on the microwave and the wireless in the area can go bad. I've also seen that with a few refrigerators. And then we've also seen access points that will go bad. In particular, there's some Linksys access points that I've seen that lose all their settings. And it's better to have an enterprise thing like a Unify or a big office style access points. They tend not to lose their information as well or as rapidly. And then you can sometimes have the antenna in a laptop or something go bad as well. I've seen that one. So how do you track some of these down? You open up multiple windows and you ping with the minus T. So a ping minus T is, where's my, come on. It's not letting me jump between these. All right, here we go. Okay, if you do a ping by itself, it just does a few pings. But if we do a ping minus T, it pings and it just keeps going forever. And what you do is you have a few of these pings running and you ping different spots in your network and it will help you see which ones are fast and which ones are slow. So when you have a complex network, the ping minus T will, you have a few of those windows running. So this here, if we look, if you can see the numbers, these numbers here are mostly okay. But this one here has some longer ones, a 29, a 36. And so by doing this, you can figure out what types of issues you have, where the problem is in common. And you ping every step of the leg, and some of them will be worse, and then that tells you where the problem is usually. You always want to verify that you can ping the router. So you should know your gateway and be able to ping it. And then you can also look at the lights on your router, gateway, and switch. The lights are usually will tell you some of the most important things about your network. Usually they will flicker, and a flickering light where they're blinking, I say they're happily blinking. And if you've used one, you should know, oh yeah, they just blink a lot. Ones that are bad are either if it is completely off or if it is completely solid. A completely solid usually means that it's a network loop involved, or if it is off at all, that means that the wire is bad or there's an issue with the link that it's connected to. So those are two things to be looking for. If you can ping it, then often you then open a web page to it to check the status of your gateway. And then you also do that to your switches. You look at the different switches on the way. If you have managed switches, which are very nice, if you have the option of getting managed switches, I always tell people to make sure you have the managed switches, because then you can ping the switch itself and see if it is alive, and then you can also look at the switch remotely without having to walk over to see it and things like that. Um, so a bad switch can be hung, and if a hung switch means that it doesn't pass any traffic through it at all. It can be bogged down, so it can be really slow, and so everything that goes through it just comes out really slowly. Um, so if you can either ping the switch or ping something on the other side of your switch, you can usually determine, if it just comes back really slowly on the other side, and you ping multiple things on the other side of your switch, then you know that the switch is slow. Or if nothing gets through at all, then you know it's hung. And usually what you do is you reboot it. In both those two cases, the first thing to do is to reboot it. If it continues after a reboot, then you may have to replace your switch. Trace route is something that tells you the layout of the network outside. It shows all the routes, the routers along the path. So usually inside your local network, you do not have multiple routers. You may have VLANs, so you may have one router between things, but usually the trace route only shows the outside. But trace route is very good. It's kind of like that MTR that I showed in the beginning that had all the showed you all the steps along the way and the pings that it was taking. Traceroute only looks at each one time, while the MTR stands for Matt's Traceroute, and it's basically a better version of Traceroute. Um, and then Ping Plotter is also like MTR. Ping Plotter has a free version, which a lot of people will use. But MTR is almost the same, and it's completely free. And this is where you download the WinMTR that I showed early on. And I believe that my presentation should be available to you, so hopefully you can download it and have these links. One of the other issues that we often have on a network is that the DNS is not working. So sometimes people will say, I can't connect to anything, but if you do a ping .8.8.8.8, it will work fine. And the 8.8.8 and 1.1.1.1 are two easy things to remember, and so they're probably the most pinged ones because you want to be able to ping something with a number that you remember. By pinging it, it doesn't require DNS, and so it doesn't have to look it up. So this will check the path to the internet, and it will say your internet connection is fine. But then if you ping it by name, ping google.com, it will say it can't find google.com, and that's because the DNS is broken. So if the DNS is the problem, then you may have to restart your DNS server. And again, you kind of have to know your own network to know where your DNS server is. If you're using Active Directory, you may restart the service. You usually don't reboot your Active Directory server, but you go in and you restart your DNS server in it. Or if you really need to, just restart the Active Directory server. DNS also sometimes lives on your gateway, and that may be what you need to reboot to make it happen. So DNS, a lot of people will use these two 8.8.8.8 or 1.1.1.1 as a backup DNS server. If you have an Active Directory, you don't want to do that because the Active Directory keeps track of all sorts of things internal to your network. And if you use those as backups, then what it does is it uses these things in what's called round robin. Round robin is it uses one DNS server and then it switches to another, and it switches back and forth often. And if you want to find something on your local network, if you is looking to 8.8.8.8, it won't know the internal names. So Active Directory uses DNS for a lot of important things. So you may want to have multiple AD controllers, but you don't want to use 8.8.8.8 or 1.1.1.1 as your backups. That's if you have a Active Directory domain. So Soho, that's the small office or home network. These devices are relatively poor. A lot of organizations still use them because they were easy to get. But a lot of these I've seen in the past few years, particularly in Africa, with power going in and out, these guys lose their settings sometimes, and they get reset to their default. A lot of it is bad when it loses the SSID, so you can no longer connect to it. But the really bad thing is when it gets set to the default, it turns on DHCP on a lot of these home routers. And when you have multiple DHCP servers on your network, that can cause a lot of big issues. So what happens is it starts giving out duplicate IP addresses, so you have multiple machines with the same IP addresses. Or if your IP address is different, let's say you do not have 192.168.1 dot something as your office network, if it's maybe 10 dot something if, is your IP range, none of the machines that get the IP addresses will be able to talk to anything else on the network. So they can't reach the gateway, it can't reach the internet. But also, when these guys have their DHCP turned on, they tell everybody that they are your connection to the internet, and then you connect to it, and it says, "Actually, I can't connect to the internet because there's nothing plugged into the WAN port." And so they give you all sorts of grief if they reset themselves to factory defaults. But usually, if you have a machine that has the wrong numbers, you can figure out what that machine's gateway is, open a web browser to it, and it'll tell you exactly which one it is that is giving you the grief. So uh, you that's usually the first thing you do is you figure out what IP you're getting, you connect to its gateway, and figure out what access point it is that's giving you grief. Um, So I'm just glancing at the time and what we have here. I think we're going to do okay time wise. Um, if you have two machines with the same IP, they will sometimes answer for each other. So you start pinging one and one will respond. So you try to communicate to one and the wrong one responds. This is really bad, particularly when you have a server that you have a machine that has the same IP as the server. Um, but if two laptops or something connect up, what happens is one person goes to a web page or tries to, and the packet, when it comes back into the internet, goes to the other machine. And so everything you do just doesn't really work right because communication has to go and come back, and it comes back to the other machine, and the other machine ignores it because it didn't ask for it, and so you don't get your response. Anyway, it's a big mess. Never have multiple IPs multiple of the same IP on a network. You can use the ARP-A command on the CMD, and that will give you some information about what machines have what IPs and MAC addresses, and you can often see duplicate IP addresses if you use that command. Um, so on DHCP, you always only want to have one DHCP server unless you have a Windows Active Directory. Windows Active Directory can have multiple uh, DHCP servers, but what they do is they have what's called a split DHCP. So it has two different ranges. One server has one range, and the other server has the other, so they don't actually overlap. But for the most part, you usually just set up only one DHCP server on your network. I already talked about duplicate IP addresses. So those are a lot of the things. We're kind of going through this a little bit quick because we're trying to make sure we have time for question answers here at the end. But there's just a lot of the pieces. You can have bad wires, you can have bad wireless, you can have bad switches. Your gateway can have issues, and DHCP tend to be the big issues involved. Um, with that, it's best to have somebody on your staff or you yourself who knows enough of the network to be able to do this troubleshooting. Otherwise, you kind of have to find somebody else who can, an outside company who can troubleshoot it for you. But most of these issues happen enough that it's best to have someone on staff who can do that for you. The last thing I have here is, let's see. I like to show off. I have a little program called Edu Network Builder that this QR code will do it. This again is in the if you can get the presentation information for this is on it. But when I was in working in Kenya, we built a lot of puzzles for like Frozen. This here is a puzzle about a switch where the switch froze up. And so let me put, here's my IP addresses. And so this one, if it tries to ping, the packet goes and this switch is frozen, so it doesn't do anything. So this one, we actually have to power it back off. We power it back on, and then the ping actually works. So that was, this is a little program that helps you do troubleshooting for the network. It has probably over 100 different puzzles. Each puzzle is teaches you troubleshooting for a network. So if you have the time to do that, I would suggest trying to download that program and running through it. It works on Linux and Windows. We're in the process of rebuilding it to work on a phone, but it'll probably be another year or two before you can actually do that well on a cell phone. Okay, so that is the presentation. Anybody have questions?
Thank you so much, Tim Young, for the wonderful presentation. Do we have questions for him, please? Anybody with any question?
Yeah, this is Finn from Kenya.
Uh-huh.
I can just say I have
example of the tracer. Did you hear that? Okay.
I think her mic. Go Finn.
Now, can you give example of tracer?
Yeah, this is Finn from Kenya.
Okay, somebody's.
I just wanted to say that Tim is my mentor in networks, and I'm happy to go through again the basics, and I've learned quite some new things, the Wi-Fi man and Edu network building. So I just wanted to say I've learned a lot from this.
Yeah, good. Yes. So an example of traceroute would be, and traceroute goes slowly. And I did this one 8 to 8 to 8 to 8 is. This is a number that cheats, and it is always very close to you. So it doesn't have many things. So if I do, and I go traceroute to, it's named different things, trace RT in Windows. And let's see, do I have my WinMTR? So it works very similar to my WinMTR. So we see this one is still going, while this one has already found its path. And so this is an example of traceroute where it shows the whole path going outside. This one has gotten a ways, and then it's going to okay, it just timed out, and it keeps going a bit farther. But these will show you that your connection to the outside is fine. If you do a trace route from Africa, you might see how it goes through the big pipes to the rest of the world. So you might see it pass through Africa. But anyway, so that's an example of how trace routes work. I think that was one of the questions we had.